method today. So tomorrow will be more on explanation. Your real gas versus your ideal gas, your boiling point and vapor pressure, and also your phase diagram. Okay, your phase diagram video will be up today. So talking about your Dalton's law and water displacement method today. Dalton's law. Anybody can tell me what is Dalton's law saying about? Anyone? Dalton's law. What did Dalton's law say? Bahasa biasa pun tak apa. Just very basic thing. What did Dalton say? Anyone?
Total pressure.
Partial pressure ke total pressure? Ya, Haifa, betul tu. Sekali lagi.
Total pressure of a mixture of non-reacting gases.
Okay, the total pressure will be equals to the addition, submission of the partial pressure in the mixture. Okay, so ada berapa mixture means, dalam mixture kamu ada berapa orang bermakna kamu akan ada berapa partial pressure. Okay, tak kisahlah A, B, C, D or whatsoever sampai Z pun tak apa. It depends on your mixture having how many different component. So contoh, kalau dalam beaker saya sekarang, Miss Wong saying that we have oxygen gas, we have nitrogen gas, we have chlorine gas, we have what else? Hydrogen gas. So the total pressure in this container, the P total will be the partial pressure of oxygen gas, partial pressure of nitrogen gas, partial pressure of Cl2 plus partial pressure of hydrogen gas. Agree? Dengan syarat, what is the condition yang kita boleh apply Dalton's law? Yang kamu agree with what I said. Dia ada satu syarat. Which is
Non-reacting gas.
all of them are non-reacting. Okay, all of them must be non-reacting. Sayang, syarat dia yang ni adalah wajib. Dia dengan syarat diorang tak boleh react dan hasilkan benda baru, diorang tak boleh ada kawan baru, diorang tak boleh ada kuantiti baru. Okay, bermakna kalau Miss Wong masuk partial pressure oxygen dari awal, oxygen is your 0.2 atm. Nitrogen dari awal adalah 0.5 atm. Hydrogen, for God's sake man. Kamu tak dengar ke bunyi potong rumput tu? The moment saya on Google Meet, the moment tu dia nak potong rumput. Memang tak ada waktu lain nak potong rumput ke? Oh God. I miss home. Do you? Alright, at least paling banyak pun bunyi burung je kan? So, let's say 0.3 atm. Okay, yang ni adalah let's say 0.1 atm. Kenapa diorang mesti adalah non-reacting gas? Sebab kalau dia react, katakanlah kalau dia react, apa yang berlaku contohnya oksigen dengan nitrogen react, dia dapat NO2. Kalau diorang react dan dapat NO2 and then kamu dapat Cl2 kekal, H2 kekal. Then you will have differentiation. Okay, NO2 akan berbeza dengan O2 dan N2. Kamu tak boleh tambah je. Kenapa Miss Wong guna NO2? Perasan tak NO2 adalah 1 N, 2 O. Baru dapat 1 NO2. Bermakna bilangan O2 dengan bilangan N2 yang kamu guna dan kamu tinggal akan berbeza. Yang tu satu. Kedua, the pressure that produced is because of the collision. Betul? Alright, tekanan terhasil sebab dia berlanggar. So when you collide, you produce pressure. So during the collision akan bergantung pada benda tu besar atau kecil. So kalau saya ada N2, alright, the collision between the N2 and the N2 collide. The N2 and the wall of the container collide. Akan berbeza dengan NO2 collide. Because the mass is different. The molar mass is different. The size is different. Alright, benda yang besar, collision akan menyebabkan pressure lebih tinggi. Okay, so the first condition in Dalton's law, jujur bukan total pressure sama dengan partial pressure. The first thing, all of the component must be non-reacting. The moment kamu dapat benda baru, Dalton's law tak boleh apply. Is that clear? Okay. Kalau ada reaction, Dalton's law cannot be applied. Okay. So that is your Dalton's law. And this is the first formula, I suppose, that you might come across very frequent. Alright. Yang paling senang lah. Another formula? Any other formula that you can use for Dalton's law? Anyone? Kecuali P total equals to your partial pressure blah blah blah. Ada formula lain?
PT equals to NT RT over V.
PT equals to
NT RT over V.
okay. So this thing coming from your ideal gas equation. Kalau misal susun balik, that is actually your PV equals to nRT. Agree? So, soalan dia sekarang dalam Dalton's law is, so saya nak cari total pressure, saya kena partial pressure tambah dengan partial pressure. So my question will be, kalau macam tu, partial pressure nak kira macam mana? Betul? Alright, you want the total pressure and you know that the total pressure coming from the partial pressure. Formula yang Norwesh bagi, very good. Norwesh saying that the total pressure, P total equals to the N total. Okay lah. Alright, setuju lah yang tu. So P total kena guna number of mole total. How about if I just want the partial pressure? What would be the formula if Miss Wong asking for, or the question asking for, the partial pressure of A? Anyone?
NART over V.
Kat sini I have a very huge sound pollution. I think pakcik tu potong rumput right next to me. Louder please.
NART over V.
NA, the keyword I want. Number of mole of your component A. Sangat penting. Sangat-sangat penting, especially bila kamu baca soalan Dalton's law, siapa yang dah cuba buat. You realize that in the Dalton's law, whenever we are talking about partial pressure, soalan kamu minimum 2 orang. Betul? Minimum. Bila dia minimum 2 orang, tak termasuk dengan total. So kamu ada partial pressure A, partial pressure B, and P total pressure. So number of mole pun sama. Okay, kamu ada number of mole A, number of mole B, and number of mole total. So number of mole akan tentukan the pressure that you calculate. Kalau kamu nak kira partial pressure A, guna number of mole A. And of course, if you want to be more details, the temperature of A, the volume of A, kalau dia berubah. Okay? Semua pun dia punya. The same thing apply, guys. Kalau Miss Wong nak partial pressure B, the things that will change is your number of mole. Okay? Berhati-hati. And going back to the number of mole, going back to the pressure and everything, unit, label. Especially bila kamu dah jumpa soalan ni, banyak gila number of mole, betul? Satu soalan kadang-kadang sampai 3-4 number of mole. Sayang, number of mole kena label. Label unit. And since everything coming from your PV equals to nRT, therefore your volume must be in liter as always. Your temperature must be in Kelvin as always. Your R value over here will depends on the unit of your pressure. Semua orang datang daripada PV equals to nRT last week, unit kekal. Kat sini potong rumput, kat sini burung. God sick man, I'm in zoo right now. Saya, you know, during your class, previously last batch I think, that room that I used to have class, I don't have aircon in there. And I would say my perfectionist style, I would rather having the class in hot, under the terrible hot room. Saya pun tak nak buka kipas sebab saya tak nak kelas saya ada bunyi bising. You get what I mean? And right now I have like bird chirpings around and somebody is cutting the grass right before I start my class. Sabar Miss Song. I don't like it. Anyway. Alright. Saya serius, saya berpanas hampir 1 sem sebelum saya pasang aircon kat bilik tu. Dan saya tak buka kipas masa saya kelas sebab saya tak nak bunyi angin tu dalam kelas saya. That's my level. And saya ada pacik potong rumput kat bawah saya. I feel like crying. Can you feel it? You don't you? Next thing. Alright, yang ni senang. Yang ni adalah still formula yang kita biasa guna. Saya just nak tekankan satu, number of mole and unit. Okay. Yang kedua dalam partial pressure is your mole ratio. Remember that? Okay. I think you come across a formula of this. Your PA masih adalah partial pressure A equals to the mole fraction A times with the P total. Dalam video, I use bracket. Dalam nota, saya tak guna apa. Okay, because in video, I'm trying to show you one thing. Diorang adalah darab. Okay, diorang adalah darab. So, what is actually your NA? If I expand the NA is your mole fraction, which means it's the number of mole of A over number of mole total. Okay, darab dengan your total pressure. That is another formula to calculate your partial pressure. Because sometimes, or I would say most of the time in Dalton's law, soalan takkan tanya total pressure je. Soalan akan tanya partial pressure. So selain daripada guna formula total pressure, I think the main thing is how to find your partial pressure. Okay? Formula ni senang sahaja. Jangan risau sangat dengan formula ni. You only need one thing, number of mole correctly. So the number of mole that you use over here is depends on the partial pressure that you want to find. Okay? And still, guys, back to formula, still one thing, unit. Pressure can be in any unit in this formula. Pressure can be in your millimeter mercury, your torr, your what else, kilopascal, pascal, ATM, boleh. Dengan syarat dua-dua kena same unit. Okay? Dua-dua wajib kena same unit. Any unit will do, but they must be in the same unit. Is that clear? Okay, boleh? So, that is your another formula of your partial pressure. I hope we can use it and I hope you know how to use it. Make sure kamu tahu diorang adalah darab. Okay, yang ni tak ada apa, unit kena sama. Ada masalah dengan Dalton's law? Okay. So, saya rasa nak pergi Dalton's law and then saya ajar terus water displacement method and then kita buat soalan ataupun nak pergi one by one. Kita pergi semua sekali lah, the same thing. Okay, kita ajar teori and then we go for your question. So that in the exam you know which formula to use. Okay, simpan Dalton's law a bit, we go for water displacement method. Any problem with this? Ada yang tak faham apa benda dia merapik? I think the water displacement method, the biggest formula that you have. At the end of the day, water displacement method bagi satu formula je. P total equals to P atmospheric, betul? And the P total is equals to your P gas plus your P H2O. Agree? Betul? Any problem with that? Ada orang tak faham kenapa macam tu? Tak ada? Okay. Pernah buat eksperimen water displacement method? Kat sekolah? Kalau kat sekolah dulu zaman saya dia guna besin besar. Besin mak kamu basuh beras ke basuh tu. Alright, besin warna merah beli kat kedai Eco RM2 tu. And then dia akan ambil bikar besar. Dia akan terbalikkan bikar tu. Cikgu kamu akan, kerja pertama adalah make sure bikar tu penuh dengan air. Lepas tu cikgu tu akan datang bawa satu apparatus, dia akan masuk gas kat situ. Pernah buat? Apa hidup kat zaman mana weh? Apa belajar apa dulu kat sekolah sains? Masuk makma tak? Kesian. Not your fault. Definitely not your fault. Kamu mana pernah buat salah? Kita je buat salah, betul Zul? Alright? Zul mana pernah buat salah? Kita je, pencara je. Okay, just a quick recap. What is actually water displacement method? We are displacing the water with gas. Everybody agree that gas is less dense than water. Betul? Okay? Gas is always less dense than water. And bayangkan kalau gas is more dense than water, hang nak bernafas, hang kena menyelam bawah air, baru hang jumpa udara. Okay? So, kita tak payah buat menyelam-menyelam tu sebab your gas is always less dense than water. In the other words, gas will be on top of water. Ni bahasa, orang kata bahasa mak kamu lah, bahasa pasar. Mak kamu pun pandai je. Saya sama mak saya lah. Mak saya tak berapa pandai. Jahat gila. Mak saya pandai je weh. Alright. At least anak dia pandai. Betul tak? So, what happened in the water displacement method is, malas nak ajar banyak, malas nak lukis banyak. So, I have a beaker. I started off the experiment with water where the water just enough to cover the surface. Yang warna biru semua adalah air. Okay. Then I started the experiment with this thing is full with water. Ni syarat dia. Okay. And then what happened, ladies and gentlemen, in the water displacement method, you have your reaction over here that will release gas. And the purpose in water displacement method is, I want to collect the gas. That is what we are going to do. So, we are going to collect the gas. Kita akan ada tube, kita akan masukkan tube ke dalam beaker. Alright, and then the gas will be released over there. Okay, and then what happened is, alright, what happened is, the beaker over there, eventually, air dia akan berkurang. Air dia duduk sini je. Okay. And air kat bawah ni, tadi air kat bawah hanya tutup permukaan dia. Tapi sebab air kat beaker turun, so air kat bawah akan bertambah. Sebab air tu pergi mana? Dia akan turun ke bawah. Betul? Okay, dia akan turun. Nampak tak? Air dalam beaker akan turun, air kat bawah tu akan naik sikit. So the water is going down, going out to the container out there. Agree with that? Okay. And this is where your gas located. Your gas collected, sorry. Okay, that is where your gas collected. Done? And we are going to do this experiment until when? Anybody? Kita akan buat eksperimen ni sampai?
Water same level.
Until the water is same level. Okay. Sama, saya cuba cari GIF tapi it doesn't work because the GIF is too fast. So what happened is we are going to collect the gas until the water becomes same level. The water out there, the water out here is the same as the water in the beaker. Okay, so sama, dalam ni kita ada gas. And when the water level is the same, we have one thing that I want to introduce to you. What do we call this pressure?
Atmosphere.
Thank you. Atmospheric pressure. Simbol dia adalah PATM. Memang kita terima pressure atmospheric. Boleh guna PATM ni. So that is your atmospheric pressure. Atmospheric pressure standard kita adalah berapa? 1. Betul. Azri, thank you for your finger. Baukis mengangguk, yes. So standard atmospheric pressure adalah 1. Tapi atmospheric pressure boleh berubah, depends on negara kamu kat mana, kedudukan above the sea level kat mana. Kalau kamu duduk kat Cameron Highland, mungkin atmospheric pressure kamu 0.998 sahaja. Kalau kamu duduk kat Gunung Kinabalu, mungkin atmospheric pressure kamu 0.888 sahaja. Okay? Atmospheric pressure akan berubah mengikut tempat. Sebab tu dalam soalan, atmospheric pressure tak semestinya 1. Kecuali soalan tak tanya, soalan tak minta dan dia tak bagi tahu berapa. Dan atmospheric pressure 1. Okay, dengan syarat dia tak minta Okay, that is your atmospheric pressure. We need to go fast because is getting boring. And since the water level is the same over here, so what happened is the total pressure that we have inside, the P total will then equals to the P atmospheric. Agree? Tekanan sama. Bila tekanan sama, bila benda tu ditekan pada kekuatan yang sama, sebab tu dia duduk satu level yang sama. Okay? That's why you have your P atmospheric sama dengan your P total. And why the P total is your gas plus your water?
Sorry, miss.
Why your P total is your gas plus water? Gas is the one that we collected, so we know that it's gas. Where is the water come from?
From the water.
Take your time. Enjoying my coffee still. P total equals to gas plus water. Agree, class? Jangan pandang saya semacam. Agree, everybody mengangguk. Okay, so my question quite clear, I think. Is my question clear enough, class? Understood? My question is why there is water. I thought we only collect gas. Yes, still you.
The water particle escape from the liquid.
The water particle that escape from the liquid, or in the other words, this is the entire thing using water displacement method. We are displacing the water with gas. Tapi bila air itu turun, kita tahu air akan hasilkan wap air. Remember evaporation? Alright, dia akan evaporate. So, kita akan ada a very small amount of water vapor. Wap air kamu. Bahasa Melayu wap air lah. Alright, kita akan ada a very small amount of water vapor. Because your water vapor will definitely evaporate. Okay, banyak sikit. Biasanya sikit je. Sebab tu kalau kamu tengok P untuk H2O biasa sikit je, kecil je. Betul? Sebab dia tak pernah banyak. Kita tak buat proses tu. Tapi saya tahu bila air saya makin turun, saya akan ada sebilangan kecil air yang terbebas jadi wap air. So kita nak ambil kira kehadiran wap air tersebut. So bear that in mind, when you have your water displacement method, in this area, you have the presence of your gas that we collect and also the presence of the water vapor because your liquid molecule escape and become vapor. Boleh? That's it about water displacement method. Boleh? Alright, like I say, formula dia yang ni je. Formula dia senang je, soalan dia susah. Soalan dia pun senang je. Okay, any question with this two? The entire concept of your Dalton's law and water displacement method is quite easy and simple. You just need to do one thing, apply them in your question. Okay, saya rasa saya ada 9 ke 10 soalan, tak ingat. Soalan mana yang kita nak bincang dulu? If can, I will discuss everything, but I want to discuss the one that you want me to discuss. Yang mana tak boleh buat? Kalau semua boleh buat, kita boleh habis kelas. I think I should do a video of drinking coffee. I think that will have more view than my content video. I thought you like all those random video kan? Video orang tak buat apa, video orang tidur got like 2 million view. I'm teaching a proper content and nobody watch it. What the? Yeah, it's a good idea. I should do a video drinking coffee silently. I should do that. Yes, question please.
Question 5.
Go say question 5. Can we go for question 5? Jangan malu bertanya ya. Ada soalan kena tanya terus supaya kamu tahu mana yang kita nak buat. Okay. Quite a few questions over there. Kita ada 2 bahagian soalan. So we will do it one by one. Okay. Yang dah buat boleh check. Yang tak buat lagi, let's do it together. No, I want this. Okay. We have a mixture of 11 gram halothane, which is your C2HBrClF3. So macam biasa kita tuliskan, I have my mass of your C2HBrClF3. So the mass is 11.0 gram. Vapor. Vapor means saya letak simbol gas lah. And 21 gram of oxygen exerted a pressure of 810 millimeter mercury. So the mass over there, saya nak berbetul soalan saya boleh? Oxygen gas. So mass of O2, bukan mass of O. Kelemahan soalan saya, definitely. Sorry, tertinggal gas tu. So, soalan saya next. The 810 millimeter mercury pressure apa?
Total pressure.
Total pressure. I have a mixture, benda ni sebenarnya duduk dalam satu beaker. I have a mixture that contain this and this. Alright? And that mixture exerted means produce a pressure of this. Macam Norwesh kata, that is actually my total pressure, 810 millimeter mercury. Okay? First question, what are the mole fraction and the partial pressure in ATM of each component in the mixture? I have two component in that. So soalan sebenarnya tanya, kita tengok apa dulu soalan nak. Question asking for the mole fraction of C2 HBr ClF3 and also the mole fraction of oxygen gas. Soalan juga tanya partial pressure, so we are also looking for the partial pressure of this. Cara nak tulis mole fraction, label dengan benda tu, subscript. Sama juga partial pressure, label subscript of the thing. So ada 4 benda yang kita nak cari guys. Ada 4 benda yang kita nak cari. Dan soalan stated very clearly ATM. Question 1 in ATM, but the question give you in millimeter mercury. So what do you think the first thing that you do? What do you think the first thing that you will try to convert? The pressure to ATM. Okay, kita tukar kepada ATM. Value lagi kecil, lagi senang nak kira. Can I know 1 ATM equals to how many millimeter mercury?
760.
760 millimeter mercury. So you have 810 millimeter mercury over here. Guys, semua soalan ni adalah soalan partial question. Tak kisah mid-sem atau final. If you can do all these 9 questions, you'll be extremely good to go. Soalan partial pressure tak pernah tanya benda lain. That's it. Okay, so saya pun tak buat lagi soalan senang. Soalan senang takkan nak kira number of mole tambah number of mole. Betul? So, ni je lah. Okay. So, ATM over here. Can I have the value please?
1.0658.
Thank you. Unit ATM. Okay. Next, what do you think you do?
Mole.
Mole. Soalan nak mole fraction. Guys, soalan nak mole fraction yang di mana kita tahu we need number of mole. Soalan bagi mass of that particular compound. Apa lagi nak buat? Molar mass, cari number of mole. Betul? Soalan senang. Nampak je panjang. So, find the molar mass first. The molar mass of your C2 HBr ClF3. Ada masalah dengan molar mass? Saya tak perlu tunjuk kot satu-satu. Okay? Molar mass of this dapat berapa?
197.4.
Yes, I want the 0.4 yang penting. It's a 197.4 gram per mole. Bear that in mind, kita dah lama tak buat molar mass. Molar mass kamu kena up to 1 decimal place. I hope everybody still remember that. Okay, yang ni yang saya nak lah. And then the molar mass of your oxygen gas. Siapa yang dah buat, I'm sorry, it's not oxygen, it's oxygen gas. My bad, definitely. 32.0 gram per mole. Setuju? Okay, selesai kat situ. Next thing that we want, definitely the number of mole for each and every one of them. So the number of mole of your C2 HBr ClF3 will be equals to the mass 11 gram over with the molar mass. Then you will have the number of mole of your haloalkane. Okay, and number of mole.
0.0557.
557. 4 decimal place standard sebab dia belum jawapan akhir. Okay. So next, the number of mole of your oxygen gas will then equals to your 21.5 gram over 32 gram per mole. Still
0.6719.
0.6719 mole. Yang lain setuju? Alright, number of mole saya tak di-issue kat sini. Okay. Alright, then what do we do? How do I get the mole fraction?
And total.
And
And total. Okay. N total wajib tunjuk. Ramai orang yang akan buat, I believe ramai orang yang akan buat something like this. I can show you both way. Okay, kamu boleh buat X of your C2HBr CLF3. Ramai yang mungkin akan buat, ambil terus your 0.0557, kamu bahagi dengan 0.0557 plus 0.6719. Siapa yang buat macam ni tak salah, betul je, tak salah. Okay, tapi macam mana nak cakap? Again, your calculator. Okay, again, your calculator. I'm okay for you to do so. I'm fine. Sorry, by the way, I'm not looking for the mole fraction. I want to look for the partial pressure straight away. So the partial pressure of this, kamu darab terus dengan total pressure 1.0658 atm. Okay, siapa yang buat macam ni boleh. Tapi saya prefer cara Hafizah tadi, di mana Hafizah akan cari number of mole total dulu. Sebab bila saya tanya number of mole, next thing Hafizah cakap number of mole total. So I think I will go for this first, supaya saya tak ada operasi dalam formula saya. Okay, so you will have your number of mole over here. And the number of mole I think 0.72 something. Betul? 0.7276. Right? Okay, settle number of mole. Sebab bila yang ni dah betul, number of mole yang ni dah betul, jawapan akhir saya tak payah bagi dah. Should be correct. So, the partial pressure of your C2HBrClF3 dapat berapa?
0.0816 atm.
0.0?
0.0816 atm.
0.0816 ATM unit over there is the one that I'm asking for. No, Wash, why ATM?
Soalan minta dalam ATM.
No?
Sebab total pressure is in ATM.
Thank you. If you remember, I said just now the formula when you use the partial pressure, your partial pressure of A equals to the mole fraction of A times the P total, remember? And satu je syarat saya bagi tahu. Partial pressure and the total pressure unit must be the same. Agree? Okay. Since we started off, kenapa tadi bila Miss Wong substitute saya sengaja tak letak ATM? Sebab I want to let you know, I want you to remember, I have 2 unit of pressure. And when you have 2 unit of pressure, guys, which one are you using? Kalau Nowesh kata, because the question 1 ATM, Nowesh, what would happen if I substitute this? Class, tengok.
Millimeter mercury.
Yes. So jangan jawab soalan because the question 1, because I can, you can, not I can. You can substitute with the millimeter mercury. Getting the answer in millimeter mercury, baru tukar ATM pun boleh. Okay, up to you. What I'm trying to show you over here is the unit must be the same. Sangat penting even, especially later bila dalam objective and when you tend to calculate very, very fast. So value yang keluar kat calculator tu sekarang unit apa? Yang tu kamu kena fikir. Okay, sebab I guarantee if I'm making the question, in the question, I will have a value of millimeter mercury and the value of ATM. Dan untuk kamu buat salah. That is objective. Always remember that. Okay, is to confuse you. Okay, so please, saya tak nak jawapan because the question 1. The reason why is that in ATM is only because the pressure that I use, the total pressure that I use is in ATM. This is in ATM, that's why the partial pressure is in ATM. Agree with that? Okay, dah, setuju your friend getting 0.08 something, I think just now. Blah, blah, blah. Okay, kira sendiri. My question, I have 2 things only. How do I calculate another partial pressure?
Total pressure minus with partial pressure of allotting.
Why I can use the total pressure minus with the partial pressure? Because you only have 2 things. Okay, let's say if, can I have like another slide? Sangat-sangat messy. Okay, just a quick one. Saya tulis balik apa yang kita dah kira je, the number of mole of your C2H ClF3, the number of mole yang kamu dah kira tadi 0.0557 mole. Number of mole of your oxygen gas yang kamu dah kira 0.6719 mole. Okay, and then apa yang saya dah kira? Number of mole total. You calculate the number of mole total, which is the number of mole of your C2HBr ClF3 tambah number of mole O2. So kamu dapat number of mole total. Okay, and then the next thing that I calculate just now is the partial pressure straight away. So the partial pressure of your C2HBr ClF3 is your X of that. Panjangnya nak tulis halogen. Panjang sangat. Times with the total pressure. Okay, we talk about that just now. So you have your number of mole, cara yang saya guna 0.6719. Saya nak tunjuk dua-dua cara, which is 0.0577 plus okay 1.068 atm. Kan? Okay. Norway say to calculate the another partial pressure of oxygen, we can use the total pressure, the P total minus the partial pressure of this. Sebab sekarang saya hanya ada dua benda. Bila kita hanya ada dua benda sayang, the total pressure, the P total will be equals to the P oxygen gas plus the partial pressure of your haloalkane. Okay? Nampak? So tak payah guna balik formula yang sama. Dan sayang, kenapa saya ajar macam ni? Dalam final, tak kisah objektif atau subjektif, dua-dua dapat markah penuh. So tak payah tekan kalkulator banyak-banyak dah. So the total pressure is something that we have convert 1.0658. You have 1.0658. You have the partial pressure of this calculated 0.0816. Betul? Okay. So if you got that, you will then have the partial pressure of oxygen gas. Question. Unit.
ATM.
ATM. Betul? Alright. Dapat kan jawapan? Tolak je lah. Setuju dengan cara tu? Dapat markah penuh tak? Dapat Ni adalah cara yang student suka buat. Pengalaman kita, student suka substitute terus dalam mole fraction. Tak ada masalah, betul je. Okay, boleh buat. Kalau objektif, boleh buat, tak ada masalah. But if you read my question carefully, question asking for the mole fraction as well. Betul? Nampak? So, will you still get full marks by answering like this? No. Why I started off with this method? Because I want to show you if this thing coming out in your subjective, this thing will be losing 3 marks. Kamu akan hilang 3 markah sebab kamu tak kira mole fraction tersebut. That's why I always tell my student, untuk kira formula ni, sayang, tak kisah soalan tanya atau tak tanya, mole fraction kira kat luar. Sebab mole fraction akan dapat markah. Okay, so if you have your mole, if you want to calculate the mole fraction, label them because I have 2 mole fraction. Saya nak kira mole fraction of oxygen. Kalau misal nak kira mole fraction of oxygen terlebih dahulu, then I will use the number of mole of oxygen over the number of mole total. The number of mole oxygen dah dikira 0.6719. Number of mole total yang kamu dah tambah, you have 0. Number of mole total. My N total is berapa entah? 0.6, 0.7, 2, 3, 6. Betul ke? Correct? Saya congak je.
7276.
76. Thank you. Yeah. So, if I calculate my mole fraction of water, of your oxygen gas over here, I think the mole fraction that you will get is berapa? Anyone?
0.9234.
Okay. How to check your mole fraction is correct or not? First thing, how do I check my mole fraction is correct or not? Your mole fraction cannot be more than 1. Kalau soalan objektif especially, dia tanya mole fraction, jawapan ada 1 poin lebih, 2 poin lebih, boleh buang siap-siap soal jawapan tu. Mole ratio adalah pecahan, jawapan tak boleh lebih 1. Is that clear? Okay. And how do I find, what would be the easiest way to find the mole fraction of your another component? How do I find the mole fraction of this?
1 minus mole fraction of oxygen.
Y can be 1 minus the mole fraction of oxygen.
Mole fraction of oxygen plus mole fraction of allothane is equals to 1.
Mole fraction of all your component must be equals to 1. Tak kisah kamu ada berapa component. If I'm having 3 component, mole fraction of A plus mole fraction of B plus mole fraction of C must be equals to 1. And since I only have 2 mole fraction over here, so to find another mole fraction, you can simply use 1 minus kawan seorang tadi. Nampak? Easy. So, ada 2 benda kat sini yang kamu suka tinggal. 1, mole fraction kamu tak suka tunjuk. Kamu suka kira terus dalam soalan. Alright, dalam jawapan. And I don't like it. Sebab kalau dalam subjektif, mole fraction mesti akan dapat markah. So, mole fraction kira kat luar. Pertama. Kedua, hasil tambah setiap mole fraction dalam soalan mesti kena sama dengan 1. So, kalau kamu ada 3 benda, hasil tambah 3 kena sama dengan 1. Mole fraction, bukan number of mole. Okay? So, the mole fraction over here will be your 1 minus 0.9234. And I believe your answer, kalau saya congak, 0.075 tak 566. Betul ke? Pandai lah. Okay. Agree? Next thing. Mole fraction ada unit? Mole fraction ada unit?
Tak ada.
Jangan letak unit. Selalu sangat kita jumpa mole fraction dalam mole. Saya tak tahu macam mana mole fraction boleh dalam mole. Sebab kamu ada unit mole, bahagi dengan unit mole, the mole cancel off. Mole fraction tak ada unit. Okay? Sama, berhati-hati dengan unit. So, the unit of the pressure that you calculate will be depends on the unit of the total pressure that you use or vice versa. Okay? Mole fraction will forever have no unit sebab dia adalah satu pecahan. Benda basic kat sini. Okay? And last but not least, the total of every fraction that you have must be equals to 1. Okay? Cara yang paling senang. And of course, if you want to repeat this method, untuk kawan ni tak ada masalah, betul je. Kalau kamu tak confident bila masa boleh tolak, bila masa tak boleh tolak, repeat je cara tu, tak ada masalah. Number of mole semua dah ada, guna je lah. Okay? Soalan saya, susah atau senang? If you ask me, susah lah teacher, saya akan jawab tak susah, panjang. Betul? Dia panjang, satu. Kedua, bila dia cerita pasal Dalton's Law, kamu perasan bila kita buat soalan Dalton's Law banyak lagi nanti. Dalam Dalton's Law, kamu akan buat calculation yang sama 2-3 kali. If you have a component A, B, C, soalan bagi mass, kamu nak cari number of mole. I don't know whether you realize or not, you're repeating the calculation. So if you ask me, susah ke tak? Tak susah. Dalton's Law is the easiest thing. Satu, Dalton's Law panjang. And Dalton's Law banyak value. So in Dalton's Law, what is the most important thing? Label. Siapa punya? Yang ni penting. Alright? Dalton's Law akan jadi disaster kalau yang kamu kira, kamu pun tak tahu dia adalah apa. Yang ni disaster. Dalton's Law tak susah. Dalton's Law panjang. Tulis semua benda, label semua benda, kira semua benda, you will be good to go. Okay? Masih balik kepada label sayang. Masih balik kepada label. Boleh buat? Simple question. Okay? And the question is not finished yet. Saya ada another part of the question. Let's see. Only halfway. Sebab saya cakap kan, soalan ni semua soalan exam. So, soalan exam tak adalah soalan pendek-pendek. Okay, another part of the question over there is blah, blah, blah. How would the partial pressure change if the gas mixture was placed in 10-liter container and at the temperature of 27 degrees Celsius? Saya ambil balik partial pressure tadi. Partial pressure yang kita dah kira tadi, saya ambil dulu. Sebab soalan tanya, how would this partial pressure change? So the partial pressure of your haloalkane over there just now is your 0.0816 atm. Partial pressure of your O2, 0.98. Betul ke? 0.9842 atm. Betul? Okay. So the question is, how would this partial pressure change if the container is 10 liter, if the temperature is 27 degrees Celsius? Rasa-rasa, kamu kira guna apa?
P equals to nRT over V.
PV equals to nRT. Betul. Alright, PV equals to nRT. Tapi, the confusion is, do we still use the partial pressure tadi? No, because we know this guy will change. Kalau diorang akan berubah dan kita tak boleh guna combined gas law. Kita tak boleh guna P1V1 equals to, alright, over T1. Kenapa tak boleh guna yang tu? Sebab the beginning, the first part of the question, the first part of this question, dia tak bagi tahu condition dia apa. Kalau the first part of question dia ada bagi condition, saya nak bagi a view for you right now. Kalau the first part of this question dia ada bagi volume berapa, temperature berapa, tak payah guna P1V1 equals to P2, tak payah guna PV equals to nRT. Boleh guna combined gas law terus. Betul? Okay? Tapi sekarang kita tak ada. You only have the condition after. So like Norway said, we can use your PV equals to nRT. So in the PV equals to nRT, temperature must be in Kelvin. 27 degrees Celsius in Kelvin, please.
300.15 Kelvin.
300.15 Kelvin. Kalau Norwesh tak ada hari ni, MC kelas ni akan jadi bisu. Okay, thank you Norwesh. Thank you for your support. So 300.15 Kelvin. Agree over that? Okay, let's look at your PV equals to nRT. That is for my halogen. That is for my oxygen gas. So the PV for it must be the pressure of your halogen, will be the number of mole of your halogen, okay, RT over volume. Agree? Sama, pressure of O2 must be the number of mole of O2, RT over volume. Okay? So, pressure is the one that we are looking for. We need the R, temperature is given, volume is given, R, temperature, volume. So, what will remain the same when the condition change? What will remain the same when the condition change?
Number of moles.
Thank you, Safan and Aiman, I think. Thank you. You guys are there. Number of mole. Okay. So, number of mole must remain constant. So, yang akan kita guna bukan partial pressure. Partial pressure pun kita guna, simpan saja. Number of mole of your halogen that you have calculated at the very, very beginning. 0.0557 mole. Number of mole of your oxygen gas that you calculate at the very, very beginning. Yang ni kita akan guna. Okay, my question, what is your R that you use?
Zero point 0.08206.
0.08206. Alright, 0.08206 means your pressure calculated will be in what unit?
ATM.
ATM. So temperature 300.15 Kelvin over the volume 10 liter. Okay, you will then have your answer calculated is in ATM because Go decided to use your R is 0.08206. So siapa yang guna 8.314 boleh. Siapa yang guna R 8.314 boleh kalau jawapan kamu in kilo Pascal. Kenapa saya kata boleh? Question only ask for the partial pressure. Betul? Soalan tak tanya partial pressure in what unit. Okay. And next, over here, number of mole oxygen 0.8719. R remains 0.08206. Temperature 300.15 over volume 10 liter. Answer again is in ATM. Boleh? Cara betul? Soalan? Dah. Semua dah ada sebab saya nak tanya soalan dan soalan saya kamu kena ada value dia. Dah. My question. Predict the initial condition. Okay. My question. I would say this is our second condition. Sebab soalan tanya, what would be the changes of the pressure at 10 liter, 27 degrees Celsius? Betul? Okay. My question, predict the first condition for this. Predict sahaja. Kita tak perlu value. Saya hanya perlu tahu, let's say, kalau saya ada constant number of mole and let's say the volume constant. So my question, pressure berubah kan? Pressure confirm berubah. So what do you think at the beginning, the temperature is higher or lower than 27 degrees Celsius? Predict sahaja. Anyone?
Lower.
Saya dengar bunyi tapi louder please.
Lower.
Alia kata lower. Semua terus mengangguk. Betul? Alia dia percaya gila kat hang. Saya ajar pun dia tetap mengangguk macam tu. Alright. Alia say your initial temperature, alright, your T1 before the changes is lower than 27 degrees Celsius. Yang lain? Setuju? Kenapa temperature lower? Alia, can you explain a bit?
Sebab dekat second condition tu dia punya pressure lagi tinggi. So,
Pressure dia lagi tinggi. Saya tak bagi jawapan akhir lah sebab jawapan kat depan tu pun kamu dah akan nampak dia lagi tinggi. Okay, so kalau pressure lagi tinggi, kenapa temperature akan jadi rendah?
sebab pressure directly proportional to temperature.
Because pressure is directly proportional with temperature. Betul? Setuju? Alright. Walaupun pressure directly proportional with temperature, kita tak jumpa benda tu. Okay, kita tak jumpa benda tu. Alright, tapi kita akan nampak dalam your combined gas law. Nampak tak? Kita akan nampak kat your combined gas law. Okay, your pressure is directly proportional with your temperature. Okay, kita nampak kat situ. So over here, the pressure in the new condition, in your second condition, pressure is higher. Over here, the pressure is lower in the first condition. So bila pressure is higher and pressure is directly proportional with the temperature, bermakna suhu kat sini kena tinggi. Suhu kat sini kena rendah. Nampak? Okay. Dan soalan boleh tanya tak? Oh yes, soalan mesti boleh tanya. Dan bila soalan minta predict, tak payah kira. Kamu hanya perlu bagi tahu higher or lower than that particular pressure. Melainkan soalan suruh determine the initial or whatsoever. Dan yes, kita kira. Okay? Boleh? Nampak? Question? Thank you. Setuju kah? Setuju kah? Okay. So pressure lower, straight away temperature also lower. Okay. Setuju? Alright, we will have all these questions along the way because they are still guesses. Alright, because they are still guesses. Any question for this question? Boleh buat? Senang? We are still using a lot of PV NRT, so be very careful with your PV equals to NRT. Okay, unit. Lagi soalan lain? That is your question 5. A long one, but it's not a hard one. Lagi soalan lain?
Number 2.
Number 2. So, salah nak simpan bagi besar sikit. Kenapa tak boleh simpan? Oh, never mind. Okay, a 500 ml vessel contains 1.35 gram of chlorine gas has a pressure of 760 millimeter mercury. I love this type of question. Ada 2 container. Vessel is actually a container. Alright, so the first vessel is a 500 milliliter, contain 1.35 gram of chlorine gas. And the pressure in here, not total, the pressure in here is 760 millimeter mercury. 760 millimeter mercury, 1 atm. Setuju? Tak payah convert pun kita nampak. When a certain amount of oxygen gas is added to the vessel, so I have oxygen gas will be added. Okay, the pressure rises. The new P total is equals to 865 millimeter mercury. Okay, assume all the gas are not reacting with each other. Bermakna oxygen remain oxygen, chlorine remain chlorine. Temperature remain constant. T is constant tapi dia tak bagi tahu. Soalan tanya satu benda je, mass of oxygen gas. Okay, so the question asking for the mass of oxygen gas that added into the container. By looking at the question, before fikir mass of oxygen gas sayang, saya ada 1 pressure, saya ada 2 pressure. From these 2 pressure, apa yang kita boleh dapat dulu? Anyone? Except Norwesh, kita panggil nama. Kalau saya tak panggil nama, yang tak buka mulut memang takkan buka mulut. Nabil, from here, what can you get from these 2 pressure value?
PCl2, PO2.
PO2, kita boleh dapat PO2. So Nabil, nak cari PO2 macam mana?
PT minus PCl2.
Setuju kelas? So the pressure at the beginning, the 760 millimeter mercury is actually your PCl2 because at the beginning we only have Cl2 gas. So the P total sama dengan PCl2 lah, ada seorang je, betul? Tapi bila saya campur oxygen gas, the P total over here is actually your PO2 plus your PCl2. PCl2 dah ada 1 atm 760 millimeter mercury. So nak cari PO2, tolak, ambil 865, tolak 760 mm mercury ataupun tukar kepada ATM. Kamu buat cara mana? Kamu tukar ATM tak? Kamu tukar ATM. So over here, 865 mm mercury, 1 ATM equals to 760 mm mercury. Macam biasa, 865 mm mercury equals to how many ATM? Anybody?
1.1382.
Okay, ATM. Ya, lebih 1. 1.1382. Setuju? Saya tak kira ya, kalau salah bagi tahu. Okay. So, your P total over here is your 1.1382 minus the partial pressure of your chlorine gas 1 atm. Yang ni boleh congak terus 0.1382. That is the ATM or the partial pressure of your oxygen gas. Betul? Next, soalan nak mass. So saya dah ada partial pressure, nak kira mass macam mana? Novesh, hang on. Unit formula lain? Natasha? Orang lain? Natasha kira macam mana?
Apa dia?
Natasha kira yang ni macam mana? Saya dah ada partial pressure oxygen gas, soalan nak mass of oxygen gas. Buat tak? Cuba tak?
What?
So Natasha buat macam mana?
Yang dekat mana?
Kat mana? Saya ada partial pressure oxygen gas, soalan tanya mass oxygen gas. Natasha kira macam mana?
Darab dengan masalah je.
Zul buat macam mana?
Guna PO2 lepas tu nRT over V.
Okay. Zul kata guna P oxygen gas, NO2 RT over V. And siapa yang guna formula dia ni, dia akan stuck. Kenapa stuck?
Tak ada V, tak ada T.
Tak ada V, ada V.
Tak ada T.
Ada V ada V ada, volume ada. Okay, volume ada. P tak ada. T tak ada. Betul? Alright. T tak ada. Boleh nak dapat T? Nak guna sangat-sangat formula ni boleh, tapi cara yang sangat-sangat panjang. Saya tunjuk je dan tak ada siapa perlu kira. Siapa yang nak guna formula ni, kamu kena cari T. Betul? So nak cari T, kamu boleh buat satu cara adalah I find the temperature first. Sebab constant temperature. So apa yang kamu buat? Kamu buat partial pressure chlorine, number of mole chlorine, R, temperature, volume. So partial pressure chlorine dah ada 1 atm. R is a constant 0.08206, volume 0.5. Because in milliliter, so 0.5 liter. Number of mole pun ada sebab dia ada mass. Okay. Bahagi molar mass, kamu dapat number of mole. And in here, what are we finding is the temperature in Kelvin. Zul guna cara ni ke? Zul guna cara ni ke?
Yes.
Ya. Sama jawapan akan sama. Tak ada masalah. Saya tunjuk dua-dua cara sebab at the end of the day, it depends on how your mind think in the exam. Any method that come into your mind during the exam, use it as long as they are correct. Panjang ke pendek, baik solution kamu panjang tapi jawapan betul daripada solution hang pendek tapi jawapan salah. Get what I mean? Sebab tu saya tunjuk. Cara ni boleh buat. Dan apa yang Zul buat, kita cari temperature and then kita masukkan temperature kat sini. So you have the pressure, you have the R, you have the temperature that calculated, volume dah ada, kekal 0.5 dan kamu dapat number of mole. Betul? Betul Zul? So daripada number of mole kita cari mass lah. Agree? Alright, so Nawash, we can use this method. Alright, but we need to use twice. You need to find the constant temperature. Another method untuk membuka minda kamu sikit. Nawash, what method do you use?
XAPT. XO2 PT.
We use the mole fraction. We use the mole fraction, and in this case, we still need the number of mole of your chlorine. Okay, we still need the number of mole of chlorine. So kita nak kira dulu number of mole chlorine. Number of mole chlorine equals to 1.35 over the molar mass 35.5 times 2. So kamu akan still perlukan number of mole of your chlorine, where the number of mole chlorine in here is your 0.019 mole. Agree? Dan cara Norwesh, apa yang Norwesh buat is we are going to use the partial pressure. Partial pressure of the oxygen gas equals to the mole fraction of oxygen gas times with the P total. Sayang, kalau tak selesa nak tulis macam ni, boleh letak bracket tak ada masalah. Boleh letak bracket. Guna je bracket tu, tak ada masalah. So, the mole fraction is the one that we are looking for. Yang ni yang kita nak cari. So, the partial pressure of oxygen gas you calculated already, 0.1382 atm. So, make sure the total pressure pun guna yang atm. The unit must be the same. Okay? Agree? So, Norwesh getting the mole fraction of O2. Norwesh dapat?
Miss, mol saya sesuai salah dekat NCl2. Saya bagi dengan 35.5 saja. Jadi saya sudah salah lah. Saya baru nak kira.
Kira lah. After all, kira lah. Okay, I pun kira. I got calculator but I just lazy. Okay, I kira. Ada soalan yang saya kira, yang soalan saya baca macam tak boleh buat tu saya kira lah. Saya conteng lah kat kertas. Yang saya boleh buat tu saya baru nak kira jugalah. So kira. How can you wrong in so many things you wrong on that mole? Oh my God. Yes, Norwesh, I got it already. Anybody? Mole fraction of oxygen gas, please.
0.1214.
Setuju? Got it. When you get the mole fraction of your oxygen gas, knowing that the mole fraction is equal to the number of mole of oxygen over number of mole total. So nak senang, kamu boleh ganti terus number of mole total. Saya ada 2 orang sahaja. Kalau number of mole tak besar, tak apa. Sebab kamu ada 2 orang sahaja, so kamu boleh tulis terus. Setuju? Okay. And sorry, Cl2 bukan total. Cl2. And you have your mole fraction. Okay. You have the number of mole of Cl2. Boleh dapat number of mole oxygen? Nampak? Okay, good. Tak, seriously, okay tak? Okay. Kalau siapa yang tak okay, kalau siapa yang rasa pening lah nak kira macam ni, tak ada masalah. Kira je number of mole total. So, cari number of mole total berapa? Set. Kita kena cari number of mole total dulu. Kan? Kita kena cari number of mole total dulu. Sorry. So, I need to find the number of mole total. How can I find the number of mole total? Anybody?
Use PCl2 equals to XCl2 PT.
Use the same formula. Partial pressure Cl2, tak payah guna PV equals to nRT langsung. Mole fraction of Cl2 times the P total. Guna yang ni. Betul, guna yang ni. Partial pressure of Cl2 kita dah ada. Partial pressure of Cl2 1 atm equals to mole fraction of Cl2 is the number of mole of Cl2. N Cl2 yang kita dah ada over N total times total pressure. Total pressure pun kita dah ada, boleh substitute. Total pressure over that is your 1.1382. Okay. Number of mole total pun kita ada. Number of mole Cl2 pun kita ada. Number of mole Cl2 yang Norwesh salah kira 0.019. Yes. then you will have the number of mole total. Your number of mole total, you will have it. Yeah. We need to do this first. Sorry, I missed it. Yeah. Yes. Okay. So the mole fraction of oxygen gas dah ada, number of mole total kita baru kira, therefore from here kita akan dapat number of mole oxygen gas. Dua cara, dua-dua boleh. Zul, jawapan kamu? Number of mass oxygen, guna cara kamu tadi?
Zero 0.6925.
0.6925. Number of mole kamu dapat berapa sayang?
Salah kira. Saya dapat 0.02164.
0.02. Cuba tekan balik. 0.02 ke 0.002? 10 kuasa darab negatif 2 atau 10 kuasa negatif 3? Anybody? Mass of oxygen gas? Ataupun number of mole? Give me number of mole enough. Number of mole oxygen gas?
2.622 times 10 to the power of negative 3.
Negative 3. Zul, kira balik. Prefer cara pertama ke cara kedua? Cara pertama? Aina? Okay. No, Anis boleh guna cara mana yang kamu selesa. Cara kedua? Norwesh, Izzati. Okay. Yang lain tak pernah terfikir pun cara kedua ataupun cara pertama. Dua-dua saya okay. Dua-dua kamu boleh guna, tak kisah. I personally saya prefer cara satu sebab formula dia pendek. Tapi kadang-kadang I know saya prefer cara dua sebab calculation dia pendek, formula dia pendek. Cara satu adalah senang. Kamu tak payah fikir formula lain, kamu fikir PV equals to nRT je. Okay? Boleh dua-dua cara kita terima dalam exam. Mana-mana yang kamu dapat jawapan, I'm more than happy. Okay? And I think the mass of oxygen gas that I calculated is 0.0839 gram. Betul ke salah? Ke saya salah?
Betul.
Go dapat sama. Ke saya salah?
Sama.
Sampai okey kan? Betul Miss. Betul.
Okay. Thank you, Safan. Okay. So, both method will be fine. Anyone that cross your mind will do. Okay. Boleh guna formula mole fraction. Boleh guna formula PV nRT. Okay. And again, if you ask me susah ke? Tak susah. Panjang. Okay. Dalam ni kita tak kira apa pun sayang. Kita kira partial pressure, kita kira number of mole. Last soalan tak minta number of mole. Last soalan minta mass. And make sure mass oxygen adalah molar mass of oxygen gas is 32 gram per mole. Norwesh, make sure you times all of them. If it's a chlorine, then it's a Cl2. If it's an oxygen gas, then it's a O2. Okay? Be very careful with all this word. Your gas. Alright? Your oxygen gas is a O2. Okay? Lagi?
Number 7, Miss.
Number 7. We'll go for number 7 in 1 second. Any problem with this question? Nope. Boleh. Kita move on. Number 7. Soalan water displacement method. Let's see. Okay. Assume that you collected 1 liter of oxygen gas in a container at pressure 740 millimeter mercury at the temperature of 30 degrees Celsius. Okay. Saya lukis sikit. So I have over here is 1 liter of oxygen gas. Oxygen gas. Because of Norwich doing that mistake, guys, oxygen gas is a O2. Okay. In a container at a pressure of 740 millimeter mercury at a temperature of 30 degrees Celsius. My question adalah the 740 millimeter mercury is atmospheric pressure or oxygen gas pressure? Anyone? Yang tu soalan dia lah Fatin, saya rasa betul. Alright, soalan dia adalah pressure yang dia bagi tu adalah atmospheric atau oxygen gas?
Atmospheric.
Atmospheric. Alright, that is your PATM. So the PATM over here is 740 millimeter mercury. Dengan kata lain, that is my atmospheric pressure. And that is 740 millimeter mercury. Okay. Fatin, kenapa millimeter kenapa yang ni adalah atmospheric pressure? Cara nak tackle soalan, baca soalan betul-betul. Assume that you collect the gas. We are collecting this gas in a container at the condition. Saya kumpul gas ini pada keadaan ini. The gas is collected at this pressure and temperature. So the pressure and temperature given is my surrounding, is my atmospheric. Alright, reaction saya ataupun saya tengah kumpul gas saya pada keadaan ini. So the 740 millimeter mercury is actually your atmospheric pressure. Okay, what would be the actual partial pressure? So the partial pressure of your oxygen gas, the mole fraction of the oxygen gas in the mixture, and how many gram of oxygen was collected. Banyak benda dia tanya. Alright, tapi semua guna orang yang sama, oxygen gas. So I have 1 liter of oxygen gas over here. So first thing, kat sini kita boleh dapat terus the formula, the P atmospheric equals to the P oxygen gas plus water. Okay, setuju yang ni? So the atmospheric pressure 740 millimeter mercury equals to the partial pressure of oxygen gas. Water given 32 millimeter mercury. So kamu akan dapat partial pressure in oxygen gas is 708. My question, unit?
Millimeter mercury.
Millimeter mercury. Thank you. Betul? Alright, definitely millimeter mercury sebab semua orang guna millimeter mercury. Keep it that way first. Next, soalan minta partial pressure. How do I find the partial pressure? Anyone? Can I use the mole fraction? Question over here. Ada dua cara nak kira partial pressure. Pertama, yang kita dok guna selalu, your, what do we call that? Ideal gas. Ataupun yang kedua, the mole fraction of oxygen, partial pressure of oxygen, P total. Satu dengan dua. Kita guna yang pertama ke yang kedua? Atau dua-dua pun boleh. Anyone? Balkis?
Yang pertama.
Yang pertama. Kenapa yang kedua tak boleh guna sayang?
Sebab kita ada N total.
Kita tak ada N total. Betul. Water kat sini nak guna boleh, tak salah. Tapi kamu buat panjang gila lah. Kamu kena cari number of mole total dulu. Kamu kena cari number of mole untuk water dulu. Betul. Alright, lepas tu kamu cari number of mole untuk oxygen gas, baru kamu cari and bla bla bla. Panjanglah cerita dia. So, untuk soalan ni yang senang adalah yang pertama. Kenapa yang pertama senang? Macam mana kita nak tahu yang pertama lagi senang? When the question give you all this. Nampak? Bila kamu ada temperature, bila kamu ada pressure, bila kamu ada volume, PV, nRT jauh lagi senang. Okay? So, in the PV equals to nRT, the partial pressure of oxygen gas is the one that you already have, but you have it in millimeter mercury, so kamu kena tukar kepada ATM. 708 millimeter mercury. Can I have it in ATM, please? Berapa?
0.9316.
Thank you. 30 degrees Celsius. Can I have it in Kelvin?
303.15.
Thank you. That is your Kelvin. So, masukkan formula partial pressure of oxygen gas. Oops, masukkan formula pula. Masukkan value. Partial pressure of oxygen gas 0.9316 equals to the number of mole is the one that we are looking for. Okay. We are looking for the number of mole, and then you have your R 0.08206 because your pressure is in ATM. Temperature 303.15 Kelvin. Volume given 1 liter, volume of the oxygen gas. From there, you get the number of mole of your oxygen gas.
Miss,
Yes.
tanya Miss, bukan soalan minta mole fraction ke? Kita boleh pakai formula nombor 2 kan?
Oh, saya nak kira mass dulu. Sorry, saya lupa soalan tanya mole fraction. I'm calculating the mass now. Sorry. I forgot this. Partial pressure done. And then I move straight away to this. Sorry, I'm looking for the mass right now. I'm looking for the mass. About berapa?
0.0374.
0.0374, betul? Mole. So the question asking for the mass, sorry, I skip the mole fraction. So saya cari mass dulu. The mass over there, definitely your molar mass. Make sure it's an oxygen gas. So molar mass of your O2 is your 32.0 gram per mole. Darab 16 darab 2. So from there, you can get the mass of your oxygen gas, which is your number of mole, 0.0374 darab dengan 32 gram per mole. So you get the mass of your oxygen gas in gram. Dapat berapa?
1.1968 gram.
Norwich dapat 1.19 lebih. Syuhada?
Sama juga.
Sama. Okay. Senang. My bad. Definitely my bad. I really terlepas this one. So we are done with the partial pressure. Done. We are done with the mass of oxygen. Done. So sekarang nak cari partial pressure. So nak cari partial pressure, kita akan guna of course the formula yang ada partial pressure lah. So the PO2 equals to the mole fraction of O2 times the P total. Okay. My question, boleh tak guna millimeter mercury? Tapi guna dua-dua adalah millimeter mercury. Okay. 708 equals to the mole fraction of oxygen gas. Total pressure given 740 millimeter mercury. So you got your mole fraction of your oxygen gas over here. Tapi saya tak nak mole fraction of oxygen gas. Saya nak mole fraction of water. Please. Kalau dah ada, dia akan senang je. I want mole fraction of water.
0.0432.
Go getting 0.04 something. Haris, macam mana nak dapat mole fraction of water?
Satu tolak dengan mole fraction oksigen.
Nampak? So kalau mole fraction of water yang kamu kira betul, bermakna mole fraction of your oxygen pun betul if you use this method, and go saying that 0.04 something blah blah blah. Betul? If you are getting the same mole fraction in water, you are then supposed to have the mole fraction of O2 correct. Nampak? Dalam subjektif pun saya prefer student saya buat cara ni. Markah tetap sama. Kamu repeat PV NRT equals berapa kali pun, PV NRT tu akan dapat 1 markah je as a formula. So, bila calculation yang panjang duduk repeat, calculation yang panjang kamu repeat kali kedua tu, maka dia akan kurang dah. So, kenapa nak kira balik mole fraction sekali lagi? Tolak je lah. Betul? Okay, even dalam exam subjektif pun saya akan prefer kamu buat cara ni. Sebab tu saya ajar trik-trik yang bila masa tak hasil tambah sama dengan berapa, kamu tak payah repeat formula tu juta-juta kali. Okay, so use that method, no matter is objective or subjective. Okay, question? Yang tanya soalan saya jawab semua kah? Fatin? Okay
Yes,
kah?
Miss. Thank you.
Yeah. Saya rasa the problem arise dalam soalan water displacement method adalah kamu tak sure pressure yang dia bagi tu adalah pressure of the gas or pressure of the atmospheric, betul? Satu adalah bahasa ayat tu lah, read the question carefully then you will get it. Yang tu adalah cara yang paling traditional. Saya ada satu cara yang tak berapa nak traditional tapi senang. Senang je Fatin, tengok soalan tanya apa. Betul? Kalau soalan tanya partial pressure oxygen, bermakna yang dia bagi tu atmospheric lah. Kalau soalan tanya atmospheric pressure, yang dia bagi tu partial pressure lah. Nampak? Betul tak? Kan? I know you struggle. That is the trick. Sebab soalan budak selalu confused dengan ayat dia. And we play around with the ayat. So cara yang paling senang adalah baca ayat tak faham, baca soalan. Tengok soalan tanya apa. Kalau dia tanya partial pressure of the gas, dia takkan bagi partial pressure of the gas ke atas. Right? Hayya. Easy Fatin? Alright, saya tunggu je siapa nak tanya. Kalau tak ada siapa tanya, saya tak ajar dah cara tu. Bacalah ayat tu. Okay. Alright, more question? Lagi? Ada soalan lagi yang tak boleh buat? Soalan?
Number 9.
Soalan number 9. Oh, soalan last question. Okay. Air was passed through water at temperature 50 until 2 liter has been collected. Knowing the vapor pressure is at 50 degrees Celsius, 92 millimeter mercury, calculate the mole fraction and partial pressure of all component. Bukan soalan video ke? Tengok tak video? I think soalan video lebih kurang sama. Example last I think. Tak ingat example mana tapi ada dalam video. Simple. What's the problem over here in this question is the gas that you collect is a mixture. Kita selalu akan ada container dan kita selalu akan collect gas in the container. Betul? So the problem arise, we know that in here, that is your water. In here, we always say it's the pressure of gas. But the problem over here, the gas today in this question is not only one thing. The gas today is the pressure of your oxygen and the pressure of your nitrogen. Okay? Read the question. Air is a mixture of oxygen and nitrogen gas. Where 21% by volume is oxygen. So pakcik ni ambil 21%. Setuju? Alright, soalan ni obviously pernah keluar exam, like I say ni soalan exam ni. Okay, semua latihan soalan kamu adalah soalan exam. Ni lah yang akan keluar dalam exam, tak ada apa yang susah. Okay, so the problem arise in this question is the gas is not only one thing. But we know that in here, we are still going to have your gas and we are still going to have your water. So read the question carefully. At the temperature of 50 degrees Celsius until 2 liter has been collected. So over here, the volume total is 2 liter. At the pressure of 920 millimeter mercury. So sama juga Fatin, baca soalan betul-betul. We collect the gas at the temperature of this, at the pressure of this. Again, 920 millimeter mercury is your atmospheric pressure. 920 millimeter mercury. So we have your atmospheric pressure over here, 920 millimeter mercury. Keadaan yang kita kutip adalah 50 degrees Celsius. Diana Baukis, 50 degrees Celsius, how many Kelvin?
3 to 3.15 Kelvin.
3 to 3.15 Kelvin. The the water vapor pressure, the pressure of water at 50 degrees Celsius masih kekal 50 is 92 millimeter mercury. So over here I have 92 millimeter mercury. Soalan tanya, calculate the mole fraction and the partial pressure of all the component in the gas mixture. So ada 4 benda kena cari. Saya nak cari partial pressure O2, mole fraction O2, partial pressure N2, mole fraction N2. Agree? Anybody can tell me how should I start? Or how should you start?
Find total pressure.
Find, total pressure I have.
Total pressure equals to partial pressure of gas plus partial pressure of H2O.
Oh, your total pressure. Alright, guys. Total pressure kat sini tak boleh panggil sebagai the total pressure I mean over here is my P total of the water plus the mixture or the gas. Ni adalah P total saya. Okay, in this case P total is everything in here. That is the P total. So I think what you want over there is the partial pressure of the gas, or I would say the pressure of the mixture. Betul? Sebab soalan guna mixture, so kita stick with mixture lah. Soalan guna mixture, kita pun guna mixture. Okay. So I think we are looking for the partial pressure of the mixture. And the total that we have 920 millimeter mercury minus 92 millimeter mercury. Unit kena sama. Tak tahu berapa juta kali dah bagi tahu benda tu, unit kena sama. Can I have that value, Diana Baukis?
Eight to 8 millimeter mercury.
8 to 8 millimeter mercury. Setuju? Okay. 8 to 8 millimeter mercury is the pressure of the mixture. Soalan tanya partial pressure of oxygen and partial pressure of nitrogen gas. Di mana we know 21% of the gas is oxygen. How do you find partial pressure? Kamu kira macam mana?
21 over 100 times 8 to 8.
Yes. Perlu tak kira guna mole fraction, number of mole, PV, nRT, semua tu? Oh ya, soalan dah bagi percentage. Alright, in the entire container, 21% is oxygen gas. Another that, your nitrogen gas will be 79%. Betul? So nak cari partial pressure, tak payah guna formula apa-apa. Guna pecahan tu. Guna percentage tu. So the partial pressure of your oxygen gas will be equals to your 21 over 100, 21%, times with the total pressure 828 millimeter mercury. But the pressure that I'm saying, the total pressure I'm saying over here is the pressure of the mixture. Sebab dia ambil 21% of the gas mixture. Okay? So from that, you will have the partial pressure of oxygen gas. My question, again, unit?
Millimeter mercury.
Millimeter mercury because the partial pressure of the mixture is in millimeter mercury. So, to find the nitrogen gas, I can use this method. 79 over 100 times 828. Betul? Or, how can I calculate? No, wait, hang on. Hang on. Mimi? Ada cara lain nak kira?
Pressure of gas sama dengan pressure of oxygen plus pressure of nitrogen.
We know that the mixture or the gas is equals to the oxygen plus the nitrogen. And the gas mixture that we have is 828 millimeter mercury. Oxygen kamu dah ada, kamu dah kira, kamu dah jumpa ke atas, you have the oxygen. Therefore, you can find the partial pressure of nitrogen. Bijak sikit dah. Okay. And Safan and Aiman, can I have the partial pressure of the oxygen? Baru nak kira. Tak nak bagi jawapan, kira sendiri. Mole fraction, using the formula of mole fraction, quite simple. Equals to the mole fraction of O2 times the total pressure. So kat sini sama. Partial pressure kamu dah jumpa, kat sini pun sama. Partial pressure N2 equals to the mole fraction of N2 P total. So mole fraction yang kamu kira dari sini, mole fraction yang kamu kira dari sini. So kamu akan dapat, partial pressure dan kamu akan dapat mole fraction. Okay. Setuju? Am I going too fast or I'm so bad because I decided not to give answer? Is that okay? Okay. Semua orang guna cara yang sama? Siapa yang nak guna 1 tolak pun boleh ya. 1 minus, mole fraction of N2 equals to 1 minus mole fraction of O2. Boleh, tak ada masalah. Alright, boleh, tak ada masalah. Sama je. If you understand how to use both of the formula, you are very, very good already. Okay? Am I going too fast or am I going too slow? Okay, boleh. Menjawab soalan? Dah? Ada soalan lain? Saya bagi cara je, saya memang tak bagi jawapan ya. Awal-awal tu saya bagi jawapan lah, hujung-hujung ni saya bagi cara je. Okay. Alright. Ada soalan lain? Syuhada, soalan lain? Iman, ada soalan lain? Question? Tak ada? Soalan ni boleh guna PV equals to nRT ya kalau nak, saya rasa, tapi sangat panjang. So tak payah guna cara ni. Okay? Tak ada soalan lain? Question 1, going all the way back to your question 1. Tenang. Tukar semua mass kepada number of mole, cari number of mole total, kamu akan dapat total pressure. Guna P. Change all this to mole, and then from that you will get the number of mole total. So you can use your P total equals to N total RT over V. Betul? Okay. So to find the partial pressure, cari salah seorang dulu. Boleh guna cara ni untuk, let's say, nitrogen oxide. So you have your mole fraction P total. Sebab P total dah ada. So mole fraction pun akan dapat sebab kamu ada number of mole, kamu ada number of mole, kamu ada number of mole total. So satu lagi will be the P total minus the PNO equals to your PNO2. Okay? Setuju? Okay, jawapan tak ada macam biasa. Buat sendiri. A sample of oxygen gas collected over water 20 degrees Celsius and a pressure of 738. Soalan saya. 738 is what pressure? Pressure of the gas or pressure of the atmospheric? Aiman?
Atmospheric.
Atmospheric. Again, kalau tak pasti, tengok soalan. Soalan tanya partial pressure of oxygen gas. So kalau soalan dah tanya partial pressure of oxygen gas, pakcik ni mesti atmospheric. Nampak? Okay, see that? Simple. So that is your torr. Your atmospheric pressure is in torr right now. You said the volume is the volume of your oxygen gas. Given the vapor pressure, that is your pH2O. What is the partial pressure of oxygen gas? Boleh. Kalau kamu kekalkan jawapan kamu kat torr pun tak ada masalah at this moment. Okay. What would be the volume of oxygen gas at dry, when dry at STP? We talked about STP last week, remember? Okay. So I want the condition for STP. Haris, temperature and pressure for STP, please.
Zero degree Celsius. Pressure 1 atm.
Pressure 1 atm. So kat sini soalan tanya volume of the oxygen gas at dry STP. So apa yang kamu kena buat? But from the A, kamu kena cari satu benda dulu. Number of mole of oxygen gas. Sebab number of mole of oxygen gas yang akan kekal. Betul? Okay. So kamu kena kira PV equals to nRT 2 kali. Kamu kena kira PV equals to nRT 2 kali. PV equals to nRT untuk kali pertama is the temperature, is the pressure of your O2 calculated. Volume is 0.31 liter. Number of mole is the one that we are looking for. R is a constant. Temperature is 293.15 Kelvin. Ni adalah PV nRT kali pertama. PV nRT kali kedua, kamu akan kira sekali lagi. Tetapi kali ni kita akan ada number of mole. Number of mole yang kamu kira, kamu akan bawa masuk ke sini. Pressure is 1 atm. Temperature is 273.15 Kelvin. R is a constant. Volume is the one that we are looking for. Nampak? Bear that in mind, bear that in mind, the things that doesn't change is number of mole. Quantity dia tak berubah. Pressure boleh berubah, volume boleh berubah sebab dia boleh kembang, dia boleh kecut and so on. Tapi number of mole takkan berubah. Bilangan takkan berubah. Okay? Boleh? Cuba buat.
Miss,
So, kalau saya, yes.
kalau guna PV over T tak boleh
PV over T. Boleh? Boleh. Boleh? Ni satu. Thank you. Boleh. Tak terfikir. Saya bagi tahu dah soalan senang saya tak buat. Saya baca soalan saya bagi jawapan terus. Boleh. P1 combined gas law. Very good. Boleh guna. Very good. Okay, boleh guna. Lovely. Make sure pressure unit sama, volume unit sama, temperature mesti dalam Kelvin as always. Okay? Boleh. Good. I'm happy. Good. Alright, cuba buat soalan 4. Tak boleh buat soalan ni, aku ketuk kepala aku sampai penyek tau. Aku sumbat kepala kamu dalam toilet, aku flush bagi bersih sikit. Jahat mulut. Tak ada, saya tak buat macam tu sayang, saya gurau je. Saya tak pernah buat macam tu kat kamu. Soalan senang, tak nak ajar. Soalan 6. Sama Oh, nasib baik yang sama soalan senang. Itulah sama, sorry. Soalan ni tak ada siapa nak tanya? Sebab kamu tak ada siapa nak tanya. Anybody yang dah buat, saya nak jawapan. What's that? Anyone? Anyone want to offer your answer?
Iblan dah buat, Miss.
Ha? Mai jawapan. Dua orang tu mai jawapan. Islan, mai. Islan ke Safan ke? Alhamdulillah.
Nak
Mai.
final answer ke Miss?
Apa dia?
Nak final answer ke apa?
Saya nak WhatsApp. I want to see how you calculate it. Come on. Saya tak tunjuk kat kawan. Jangan risau sayang. Saya nak tengok apa yang kamu kira je. Safan akan share jawapan bertulis. Anybody want to share your final answer? Except Go. Except siapa yang selalu buka mic? Nowesh. Orang lain? Anybody yang dah kira? Saya rasa soalan minta banyak benda. Mole fraction of neon, mole fraction of argon. Betul. Partial pressure of neon, partial pressure of argon. Yep. Anybody? Soalan senang ni. Soalan senang dan I love it. One of the favorite question in our exam. And definitely coming out in your topical test later on. Soalan antara soalan favorite dalam final. Ada siapa-siapa yang dah buat? Nawesh tak sabar nak buka mic tapi Miss Hong tak bagi. Anyone? Tak ada tak nak bagi. Safan nak hantar tak kat saya?
Dah Miss.
Dah, saat. Saya tak share jawapan Safan, jangan risau sebab saya nak kamu buat. Saya pelik tak ada siapa tanya soalan 8. Sama ada saya ajar kat video sangat-sangat jelas ataupun hang tak tengok pun video and okay, kita tengok jawapan Safan saya. Betul? Tak dah.
Ya, Miss.
Sat. Saya tengah baca soalan saya, Sat. 2.5, 1.5. Okay. Partial pressure betul. Mole fraction. Mole fraction salah sayang. Mole fraction salah, Safan. Sangat salah. Kenapa P total dua-dua boleh berbeza? Bukan dua-dua sekarang duduk dalam kontainer yang sama ke? Kenapa P total salah? Kenapa P total berbeza? Kan, Safan? Okay.
Miss.
Yes.
P total.
Cuba tengok P total yang kamu kira kat bawah tu, dua-dua bila kamu bahagi, kenapa kamu bahagi dengan P total yang berbeza? Fikir balik P total itu apa?
Okay Miss, baik-baik. Saya nampak. Sorry.
Anybody want to share answer? Let's say I want just one answer. Can I have the partial pressure of neon?
0.1485.
0.1485. Okay. Tapi Safan dapat 0.1481. Siapa yang salah tekan? Substitution Safan betul dah.
Saya dapat 0.1481 sama dengan
81. Sayang kira balik 0.1481. Betul? Partial pressure of your neon. One last question before we end. In this question, there is one law that we apply. Other than your, what do we call? Other than your Dalton's law, because you have your gas mixed up. Your neon mixed up with the argon. Other than that, we have another law that we apply. What is that law?
Boys law.
Go say Boyle's law. Yang lain setuju? You will use the formula of your P1 V1 equals to P2 V2. Betul? Because the changing of volume. Okay, cuba buat soalan ni. Esok kamu kena tunjuk jawapan kat saya. And soalan senang, saya tak bagi banyak pun soalan. Sebab inilah semua bentuk soalan yang akan keluar dalam final nanti. Okay, start doing your cam friend and start doing the cam friend question. Or the objective question especially. And then, esok kita akan pergi kepada a few things. Most of them is your explanation and your theory. Okay, tak ada calculation sangat esok. Bukan tak ada calculation sangat, tak ada calculation esok. So you will be telling me a few story. The real gas and the ideal gas. What makes your real gas and ideal gas different? One. Second, in the liquid, saya nak bincang satu benda je. Vapor pressure and boiling point. Okay, pergi tengok vapor pressure and boiling point. Last but not least is your phase diagram. Phase diagram video will be up today. Hopefully as soon as I can. Saya dah record tapi saya tak dan edit lagi. Okay, so kita akan habiskan topic 5 this week and we will be going into your topic 6 next week. Is that okay? Okay. Akan ada benda yang saya tak ajar dalam kelas sebab benda tu teori yang terlalu teori. Kalau saya ajar, kau akan tidur untuk 2 jam berturut-turut. So, ada benda yang kamu kena tengok. Video is complete. That's why your video semua dalam video kecil-kecil by subtopic. Watch all the video. And I already make it as short as possible. Ada video yang saya rasa tak lebih, majority tak lebih 30 minit. Okay, so watch that, the simplest that I can give. Boleh? Okay. And if nothing else, I think I'll see you tomorrow, maybe with this question and a lot of theory. Okay, a lot of theory. Okay, any question? Dalton's law, okay. Water displacement method, okay. Great. Kalau maybe saya bagi quiz tiba-tiba esok, tengoklah. Okay, kalau tak ada apa, I think that's it for today.
Thank you, Miss.
Thank you, Miss.
Yes.
Thank you, Miss.